Good evening, all of you. I hope you are very well. And on previous class, I have discussed about the shear force and bending moments. It is the I think it will be the third class of you. Okay. Uh, I will discuss about the shear force bending moments. How it will be appears when different loading conditions also the different beams. Okay. First of all, you can see on the boards uh, I have drawn the diagrams of simply supported beams, cantilever beams, and loading conditions, and how it will be appears to you. Okay, so you can see here the cantilever beams, a cantilever beams uh, which is with the point load. The shear force diagram is just like a rectangle shape. So the shear force will be the how many times the load, the value of the load, it will be same value of the shear force. Okay, and the BM bending moment diagram, it will be rectangle triangle shape. It will be at the end portion where the force is applied at this BM is 0, where the bending moments, the cantilever beam is supported at this point, the bending moments is maximum. The maximum is WLs. Also you can see the cantilever beams with uniformly uniformly distributed load. This load is some diagram is like this, something is like this looking. That is the of its shear force is the shape will be rectangle, sorry, triangle. At this point the shear force will be maximum, and at, at this point is shear force is value is minimum or 0. And in case of bending moment of this beam is also just look like a um, parabolic rectangle, parabolic type shape. Parabolic type shape, this line is not completely straight line, but these lines follow the parabolic flow, okay, path. So at that both the points, at that points is maximum, which is value is WL square by 2, and another point is 0. Very good. So on the uppers, on the right hand side, you can see cantilever beams with a uniformly varying load, UVL load. The shear force and bending moments both are is rectangles, and also the BM bending moment shape is just parabolic flow path. So the value is the shape is WL square by 2, and WL square by 6 is the maximum value of the bending moments of this cantilever beams with uniformly UDL loads at a times. Another case, the simply supported beams with the point load which is acting at the midpoints of these beams. Just look, have a look. The shear force at these points, at A points, is a maximum, and at the first bending moments is minimum. Its value will be the minus WL by 2, and another sign is indicates the positive signs. It is the W by 2. Okay, sorry, it is a W by 2, it is a minus sign, and it is a positive signs. At these points the shear force changes its signs from positive to negative at this point, so the bending moment will be maximum. So in case of, we can see the bending BM diagrams, you can so have a look at the same points where the shear force is change is signs. At this point the bending moment is maximum, just like it's like a rectangular shape, triangular shape. Okay, on the next point we can see simply supported beams with the UDL load just looks like this. The shear force S-shape diagram is, but in case of the point load, the S-shape diagram is was rectangle, but the UDL, in case of UDL load in case of ideal load, the shear force is rectangle, triangle, but the change is sign at this point, midpoint, positive to negative. Here you can see the bending moment of this diagram is just like a parabola floor line. At this midpoints where the change is signs, the bending moment of this shear force is maximum, so its value is the WL square by 8. Okay. Also, I've not mentioned it. The SF shear force of this simply supported loads is WL square by WL square by W into L by 2. Okay. In case of UVL load, the UVL load, uniformly varying load, the SF diagram is SF diagram is follow the parabolic path, but its change is signed at the midpoint of this beams midpoint, and also the BMs at a points the SF will be of this bending of these beams is WL by 6, and another portions SF will be maximum will be WL by 3. And also the bending moment is also look like a parabolic parts, where the SF is change is signed. At that point the bending moments will be maximum, whose value is the 0.064 WL square. Okay. From these points it is clear as per the diagrams, also the loading condition and the type of beam on the different type of the beam. Okay. On next point I will discuss, it is very vital important rules that where does it may be any type of the beams where the shear force is change is signs. At that point the bending moment will be maximum. Either is bending moment diagram will be the triangle or the parabolic parabolic flow. Next point, the vital point is what is the relation between bending moment, shear force and intensity of the force. The relation between BM, SF and intensity of a force. A force is denoted by W. Okay, this is W, where the rate of the change of the shear force is denoted by intensity of the force. First point is the rate of the change of the, if SF is the shear force, so SF by dx, the rate of the change of the shear force is intensity of the load, is W by load. And next point is the rate of the change of the BM, rate of change of BM, bending moment, is called shear force, SF. So the we can BM by dx equal SF, we can write SF. So from here we can understand the rate of the change of the shear force is called bending load, intensity load, rate of the change of the bending moment is called SF of this section. Okay. On next day, I will discuss about the next chapter. Okay. Thank you. Have a nice day.